Okay, so continuing to talk about hypothesis testing, 7.4, we're going to look at hypothesis testing for proportions. So in 7.2 and 7.3, we looked at performing hypothesis tests for the population mean, mu. So now we're going to look at how to test for a population proportion, p. Hypothesis tests for proportions occur when a politician wants to know the proportion of his or her constituents who favor a certain bill, or when a quality assurance engineer tests the proportion of parts that are defective. So remember, if NP is greater than or equal to 5 and NQ is greater than or equal to 5 for a binomial distribution, then the sampling distribution for P hat is normal with a mean. So if we have mu of P hat, that just equals P, and a standard error of sigma of P hat is going to equal the square root of P times Q divided by N. So then the z-test for proportion P is a statistical test for a population proportion. The z-test can be used when a binomial distribution is given, such that NP is greater than or equal to 5 and NQ is greater than or equal to 5. The test statistic is the sample proportion P hat, and the standardized test statistic is z. So the way we find z, we have a new formula. Z equals P hat minus mu of P hat over the standard error of P hat. So we can rewrite that formula with what we know up above. P hat minus P divided by the square root of PQ divided by N. Alright, so the nice thing again about hypothesis testing is almost all of these methods are the same. Okay, the only difference that really changes is either how we find the critical values or the standardized test statistic. So here, the first step is that we're going to determine if the sampling distribution of P hat can be approximated using a normal distribution. Okay, and remember that's when we do our NP is greater than or equal to 5 and NQ is greater than or equal to 5. Okay. After we verified that, we need to state our claim. Our null hypothesis and our alternative hypothesis. Then we're going to identify alpha. And once we know alpha, we can determine our critical values. From table 4. But remember, I also say you can use table 5 and use the infinity row. Okay, since we're using our critical value, here our critical value is going to be z sub 0 again, because we're looking at the normal distribution, not the t distribution. Okay, once we know our critical values, we can determine the rejection region. This can be region or regions, depending on if it's one-tailed or two-tailed. And then step 6, we're going to find the standardized test statistic. And that's our formula z equals p hat minus p divided by the square root of pq divided by n. And then we will make a decision. And then we will interpret the decision. In terms of the original claim. Okay, so I know some of you are having issues with the interpretation. So I'm going to give you a table to help you. This is from 7.1, but I'm kind of combining it together and simplifying it, okay? So let's see here. And some of you have already given this table too, so if you want to fast forward, you can. Okay, so up here at the top, we're going to say this is our claim. So our claim is either in our null hypothesis or our claim is in our alternative hypothesis. Okay. And then we're going to have our decision. So our two decisions are either to reject the null hypothesis or fail to reject the null hypothesis. Okay, so based off of this, you can easily determine your decision or interpret your decision. So if we reject our null hypothesis, automatically that means there is enough evidence, blah, blah, blah. Okay, if you fail to reject, that means there is not enough. Okay, then depending on where your claim is, determines the next part. So if your claim is in the null hypothesis, that means there is enough to reject, and then you would state your claim, or there is not enough to reject. Okay, if your claim is in the alternative hypothesis, that means there is enough evidence to support, or there is not enough evidence to support. Okay, so using that table should help you answer those last questions or the last parts of each of your questions on your homework. Okay, so a hypothesis test for proportion can also be performed using p-values. But what we're going to focus on is still just using our rejection region. So if we look at our first example, a researcher claims that less than 40% of United States cell phone owners use their phone for most of their online browsing. In a random sample of 100 adults, 31% say they use their phone for most of their online browsing. At alpha equals 0.01, is there enough evidence to support the researcher's claim? So because this says support, we automatically know that our claim should be in our alternative hypothesis. Okay, so I'm going to go ahead and state our null and our alternative hypothesis first. Okay, So it says less than 40% is our claim. And since it's less than, that does mean that it's in our alternative. And instead of using mu, we're going to use be using p. So p is less than 0.40. And our null hypothesis, p is greater than or equal to 0.40. Okay, so now I'm going to actually do that first step that we had written on the previous page. So in a random sample of 100, so that means n equals 100. So we need to test NP and NQ. So NP would be 100 times 0.4, which equals 40. So that's good. And then NQ equals 100. Remember, Q is always the opposite. So Q would equal 1 minus 0.4, which would be 0.6. And 100 times 0.6 is 60. So again, that one works. Step 3 was to state our alpha, and alpha is 0.01. I'm going to go ahead and sketch our graph. Okay, so since it's less than, we know we're left-tailed. So you can either go to table 4 and look for 0.01 inside the table and work out, or you can go to table 5 in that infinity row. And if you do that, you're going to find that your critical value, so it's going to be negative because it's left-tailed, and then it's 2.33. And then we're going to find our test statistic. So z equals, I'm going to rewrite that formula, p hat minus p divided by the square root of p times q divided by n. So p hat is the one thing we haven't actually stated, and that's our 31%. So 0.31. So 0.31 minus 0.40 divided by the square root of 0.40 times 0.60 divided by 100. Okay, and if you plug that in your calculator, you get negative 1.83. So if we look at our graph, that would fall to the right of negative 2.33, which tells us that we're going to fail to reject. So if we want to interpret the claim, remember we start off normally with our percentage. So at 1% level of significance, there is not enough evidence to support the claim. That less than 40% of United States cell phone owners use their phone for online browsing. All right, so looking at our second example, a researcher claims that 86% of college graduates say their college degree has been a good investment, In a random sample of 1,000 graduates, 845 say their college degree has been a good investment. At alpha equals 0.1, is there enough evidence to reject the researcher's claim? So again, I'm going to start with stating our null and our alternative hypothesis. That way we know what our p-value is. So it says the researcher claims that 86%, so that means we're going to say equals 0.86, and that's our claim. So our alternative hypothesis would be not equal, so we automatically know that we're going to be two-tailed. Okay, so now we know this random sample, n equals 1,000. So we can test NP equals 1,000 times 0.86, which would be 860, which works. And NQ, so your Q would equal 0.14. So if we multiply that, we would get 140, which also works. Here we have to be careful. So we know N is 1,000, and it says 845 say their college career has become a good investment. So remember our formula for P hat is X divided by N. So if we take 845 divided by 1,000, that gives us the P hat value of 0.845. So we also know alpha is 0.1. So since we're two-tailed and alpha is 0.1, looking at table 5, moving down to the infinity row, we find that our critical values are negative 1.60 and positive 1.60. And then we can find our standardized test statistic, z equals, so plugging into our formula, we have 0.845 minus 0.86 divided by the square root of 0.86 times 0.14 divided by 1,000. And if you plug that in your calculator, you get approximately negative 1.83. So if we look at our graph, that falls in our rejection region. Oops, sorry. I'm looking at the wrong problem. If you plug that in your calculator, you get negative 1.36, which would fall in our fail to reject region. Okay, so from that, we can now interpret our decision. So at 10%, level of significance, there is not enough evidence to reject the researcher's claim that 86% of college graduates say their college degree has been a good investment. Okay, so you have 7.4 homework posted on Canvas. You also have the 7.4 optional quiz. Make sure you turn in your scratch paper if you choose to do that. Make sure you're also completing the week 3 check-in or attend a Zoom office hour. If you have any questions, send me an email or pop into an office hour.